at exactly 1:41 a.m. Thursday, March 2024. I'm making this video. This is experiment number M10. Experiment M10. That is what we'll be treating today in our practical solution series. So please get if other videos, check the playlists. I have a playlist. When you go to my homepage, that is the home of the Young Module Solution YouTube channel. You see playlists. Navigate to the playlists, and then when you go to the playlist, you check out the practicals. Okay, the playlist will show you different courses, and then you go to the practical session. You see the practicals accordingly, like the way based on how I did them. Like I said, I did them randomly. So check out and then get the explanation for each of them. So this is solution series based on the materials in which so like I do say, if you don't have the material, please you check out my number to join my platform, also 070 or 091 57293443, and also share this video to all your classmates, your junior colleague, okay, your junior colleague, and then every other person that you feel that this video is going to be helpful at the end of this session. So we'll be treating experiment M for today. So this is the manual that we are using for now. This is the cover page. Of course, the contents might remain the same, but the cover might be different, should in case you see it in the next 2025, 2026, as the case may be, upward. So we'll be treating experiment M10, like I said, where I have the solutions. I have to scan them so that it will be very visible for us to see. Please don't forget, with time, we'll be having this practical session, or this practical session live, like they're going to be practical apparatus. I'm already working towards that concerning second semester. Yeah, I think that's it. Then not just that, there's going to be an upgrade also in the solution pattern, like the way I'll be transmitting the information in my WhatsApp group. Please check it that if you're not in the WhatsApp group, maybe you are seeing this video, maybe not exactly your set 2023 sets. Please get my number 091 57 or 070633 All right, I'm a laboratory technologist at University of Port Harcourt. For now, Faculty of Engineering, Mechanical Engineering to be precise. So basically, I do practicals guides to help students overcome this issue of the poor performance exposure or no exposure to their practicals in the secondary school. So like I said earlier, there's no class for physics practical. This is your lecture for physics practical. So let's take it very serious. So you can see here I have all the practicals here, all solved. So I'm going to be explaining them one after the other. I've done M6 and M9. So I can share the video, and other ones are going to be done. So you can check them in the playlist, like I said earlier on. Okay, so M9, M10, not much. M10 is not much. M10 is not much. It's very straight and very easy practical to be done. Okay, so you can see it here. We have M10, the title there, or which is supposed to be the aim. Determine young modulus from the period of a vibrating loaded meter row. which is also called bending cantilever beam. All right. The apparatus here is the G clamp. The G clamp is what is used to hold the meter roll to the workbench. We have the weights, that is set of masses that will be given to you, 50 up to I think 100 up to 600. Then vernier caliper, which we use to measure the thickness and the breadth of the meter roll. Then the stand clamp, just to ensure that everything is in order. Okay, so it's always expected that you go through the theoretical background, all the experiment before you embark on them, to enable you have the knowledge and what is expected of you at the end of the practical session. So the experiment is a very simple one. So let's move on to this is how, okay, this is actually, we have different graph that is usually plotted for this very experiment, but unfortunately this is not the graph that we are going to be plotting, so you can ignore this very section of the work. Now let's go to the method. It said use a G clamp to hold a meter roll horizontally on a bench with L 40 cm. Now please don't forget, if your video is not on high quality or 420, 320 or high quality or 720p, make sure that if your video is not that clear, if it's blur, it's not coming from me, it's coming from you. So ensure that you put your video in high quality. Just touch the screen of the, while you're on YouTube, touch the screen, you see setting symbol, click on it, you see the quality settings that you can check and go to high quality or 720 or 420p, so that you can be able to have a very good sight of a write-up. Okay, I can see it here very clearly on my screen. So you are going to use a clamp to clamp your meter roll such that 40 will be projected. Okay, meaning that you are going to place your meter roll on 40. You clamp it on 40. So from that 40 down to, remember the meter roll is 100 cm. So when you clamp it on that 40, from that 40 to this thing, from that 40 to 100, so you clamp it on the, you're going to clamp it on the, that is a 40 minus 100 minus 40, that is 60. Okay, you clamp it on the 60. So from that direction up will give you your 40, or depending on how you place it. If you are counting the 40 from where it's being projected down to where you clamp it, you know what I mean now, you do the calculation. But if you are clamping from, if you are checking from the other side where you have to the this, but what we after is that let the projection, okay, let the projection be 40. Let the projection be 40. So you are going to have a 40 projection. Okay, that is the word that what we mean by projection, what is going to be projected. Okay, that will be projected is going to be 40 cm for the first case. We are going to have two cases in this experiment: 40 cm projection and 60 cm projection. Okay, the instructor will be there, the lab technology will be there to guide you in case you have it and you don't get it very clear. Now section 2, then another meter rule, position vertically, is used to measure Y. Now you are going to use 2 meter rule. The first one is the one that you are going to be clamp, which is the main one for the experiment, which you are going to clamp. Then the second one is for it to be measuring. Remember, when you put a meter rule and then you add some masses, what happens is that it's going to deflect, it's going to go down like what you see in the diagram. As you add your weight or your masses, the load based on Hooke's law. Remember, Hooke's law also come into play in this very experiment, okay, whereby the body tends to the tension tends to increase, okay, as the load increases. So you can see that when this metal is being loaded, it tends to deflect, it tends to move downward, okay, and thereby creating the space you can see here. All right, so we have it there. Yeah, that is it. So now the meter rule, the second meter rule is for you to measure that very length. Now, but before you start adding masses, the instruction will tell you what to do. Before you start adding masses, what you do is that you are going to place the meter rule ordinarily and then see the deflection. Remember, the meter rule has some weights because you have projected it from the workbench, okay, from the G clamp. and then the thing has a weight on it on from the head or from the top, and it will bend a bit. You know what I mean? Now, when you place a metal and you project it, it's going to metal, the one we use, the longer one, is going to bend. You understand? It's going to bend. It's going to be a deflection. So I'm going to measure that deflection, which we call the Y naught, the original deflection or the initial deflection. Then by the time you start adding your masses, you now get the other increment, which is just similar to if you have done M9 experiment on Hooke's law. That one is directly using a vertical vibration of a spiral spring. It's the same way, because in the first stage they said you should after putting the hanging the this thing, the spring, you should measure the length, or there is an extension, okay, of the spring before you start adding the mass. Do you understand? To enable to have the initial extension, then later you now have where you now start adding the masses, the length or the extension will keep increasing based on Hooke's law. Okay, so that is what you use the second meter rule to do. Then number 3, you say width. Okay, this is now when you start adding up the masses now, or the weights now. You say width M 100, 200, 300, 400, 500 up to 600. Measure the various displacement Y. Okay, so there's going to be a displacement. It's going to be a displacement. Okay, it's going to be a displacement. All right, I'm trying to check something. There's going to be a displacement I there as you put the masses, just like we all know based on Hooke's law. The force you apply will be directly proportional to the what the extension produced. So you start adding the mass one after the other. Okay, from what we have here, when they added mass of 100, they got 1.3 cm. Okay, now before they got a 1.3, the person here did not record his initial value. Let me explain that part, please. The person did not record his initial value. Now the initial value is around 40 something. Okay, it's around 40 something you will get here. Now, with that initial value, when you add up a mass of 100, you get around, let's say the initial value is 42.5, you get around 44 or 43, okay, 0.6 or 0.5. So before you record the value here, you have to subtract. Remember, it is your final minus your initial. So you're going to be subtracting each of the values you'll be getting as you keep adding the mass from initial value. That's why you see this value is smaller. Now, some persons make the mistake in their manual. If I'd known, I would have screenshotted that part, okay, where they only recorded the 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 extension they got when they were adding the masses. You understand? You're not supposed to record that here. Let it be a rough work. It's only after you have subtracted that one you got from the initial values, which is constant all through, then you get this value. But however, if you see those ones to plot the graph, you still get something meaningful anyway. But it is better you do it this way so that it will give you values in this form. At least this is much better than when you plot the graph directly with those values you got when you were adding the masses. Please, if you have challenge understanding this explanation, make sure you join the WhatsApp group to ask more questions, please. Thank you. So, like I said, this is just alternative to practicals. With time, by God's grace, I'm trying to gather some money. Okay, that's why I want you to please at this time, please just hit the subscribe button. Just the subscribe button is not, yeah, subscription does not mean you are going to pay. Please, this is not a charge card subscription or GoTo subscription. Just hit the button. Just let it show subscribed. Do you understand? I had let it show subscribe. Then that's all. Then you just click the bell, that icon bell, just to notify you whenever I drop a video. Once I drop a video, it will just notify you that Young Model Solution has dropped a video. You can just go and watch. And of course, I reward people that comes first in my video. All right, so once you come first, watch the video, you are the first to watch the video, you see the time in there, just chat me up, screenshot, send me a DM. All right, and then of course I'm going to reward you. So that is it. So I think that is for, you do that for 60 cm too, 60 cm projection, you also get this value. So now one thing you need to know is that you need to know the theoretical background concerning this experiment. Okay, if you see now, the value is increasing as the mass increases. As the mass increases from 100 to 600, the value increases from 1.3 to what? 7.4 for that of 40 cm projection. Then the same way also for 60 cm projection, the mass increased from 100 to 600, and then the value of the extension increases from 5.9 to what? 21.9, which is very, very okay. So these are things you need to look at for. Okay, quickly we move down to the solution proper. Move on to the solution proper. Now, of course, we are going to plot a graph. It's a plot a graph of M against Y for the two cases using the same axis. All right, please, the Y here is not capital letter Y. It's supposed to be small letter Y. Okay, not capital letter Y, because in the equation we are going to encounter capital letter Y. There's so many corrections I want you to take note in this very M10 experiment. So take note of that and make sure you effect it in your manual. Feel free to effect it in your manual. All right, please. The Y here is not capital M, is small m. Capital Y here represents young modulus. Remember, we have two letters to represent young modulus. We have capital E. We also have capital Y. But here, capital Y is what is going to be used. If you look at equation 3, there's an equation that is given to us there. And you have small y and capital Y. So if you're not very careful, you just get the whole thing twisted. Over the years, students get the whole thing twisted. And for those who come across my way, I try to also correct them on what to do. Okay, so you're going to plot a graph of y against this for two cases using the same axis. Another thing again that students don't understand is this very work. You are going to do these two graphs in one. All right. Now this is also different from that of M9. In M9, that same Hooke's law I explained earlier, I mentioned earlier, which I've done the video. You are plotting the graph in two different graph sheets. But in this way, I'm plotting the graph in the same graph sheet. And I noticed that most students have problem in plotting two graphs or three graphs in one graph sheet. And they are like, how do I plot it? It's just in the same way you do your scaling. Now, what do you do? Now, check out the table of value I have here. Let me zoom it. Check out the table of value I have here. What do you notice? You notice that the lowest value is on a L40 cm axis, which is 1.3. Sorry, the L40 cm projection, which is 1.3. And then the highest value is on the L60 cm projection, which is 21.9. So you ask yourself, which scale do you take so that to cover number from that or below that 1.3 and above 21.9? So very simple. If you take a scale of 2 cm to 2 cm to 3 units, you get it. All right, 2 cm to 2 units to 3 units, I mean, on the y-axis. Now don't forget the y-axis is no more the vertical axis now. No. So that you don't mistake it. The y now is now on the x-axis. It's now on the horizontal. Because we are used to this x and y, x and y, x and y all the time. So whenever we try to explain some stuff, it gets twisted. Because you also plot a graph of m against y. So m is on the vertical axis, while this y now will now be on the horizontal axis, which is your extension, while m is your mass. Are we good to go? All right, thank you. So the scale is going to take 3 cm or 2 cm, I mean, to 3 units. All right, on the horizontal axis, which is the y-cm axis. So you take 3, 6, 9, 12, 15, 18, 21. And it can take more than 21, 24. Some have up to 24, some have up to 26. You see how space there, you continue. If the space is not okay by you, take it landscape. All right. Then for the M axis, of course, the scale are very easy. 3 cm to 100 units or 3 cm to 100 grams on the M axis, which is the vertical axis. So you take every 3 cm, 100, 200, 300, 400, 500 to 600. Very simple one. All right. If you have issue taking scale, please always let me know. I know that the scale is a major problem to most students right from their secondary school. So chat me up on the WhatsApp and let's get this thing done. The number again is 091 57 29 3443, or take my second number 070 633 77552. Right, let's go. So after taking your scale, after plotting your graph, question 2 says calculate the slope S40 and S60 respectively for L40 equal to 40 cm and L equal to 60 cm. That means the two projection you did. Okay. And please don't forget, lest I forget also, after plotting your graph, please label your your graph. That means differentiate the graph. I mean, the one of L40, put the L equal to 40 cm. The one of L60, put the L equal to 60 cm in your graph sheets. Okay. All right. So we'll move to the solution section. I'm just trying for us to review the questions now. Question 3 says the relationship between M and Y. You can see now here they use small y, not capital Y again. M and Y is given as this. Please cancel the first M equal to. They repeated M equal to twice, so cancel the first M equal to. So if you cancel that, you're going to get only one M equals to small y, BD cube, capital Y, then over 4GL cube. All right, where Y is the y-axis, the Y you plotted on the horizontal, M is the M you plotted on the vertical. Then B is the breadth, D is the thickness of the meter rule. Then capital Y is the Young modulus, which is the aim of this experiment. Then the G, that acceleration due to gravity. And then of course the L is now the length of projection. So we'll look at that in our solution guide, how we should get about it. Question 4. What is the Young modulus of the meter rule? So you are going to calculate the Young modulus of the meter rule from question 3, from equation 3. Then compare with the theoretical value. All right, so if you look at the meter rule, the material by which it was used to make the meter rule was not known. Okay, but the young module values has a range. Okay, and they are up to 10 raised power 9, 10 raised power 11, 10 raised power 10. Do you understand? So around that 1 point something to about 10 point something. So it's a very high value. So all the values are going to be calculated will fall within that range. Okay. So, but for now, we don't actually know the actual material type or the wood type that was used to make that meter rule. But that's not the case. But it's good you understand the principle behind that. Okay. So I think we can move on to the solution guide now before we finish up everything. So now this is it. Like I said, this material is a guide. I call it Invisible Tutor. Okay, it's the best selling material on campus. So go through it and see how it's did. So look at it here. Nature of graph. I say note you are to plot the two graph on the same graph sheets. All right. Then this is the title, a graph of M versus Y for two cases. So you can see what I mentioned earlier. So you label that of L40 and that of L60. Please take note the L40, the L60 will bend more than the L40. Of course, now if you project it more of the material will bend. If you project it less will also bend. So it's a practical case which is very, very simple to understand. So question 2, as we said, we were asked to calculate the slope for S40 and forward for 60. So the formula they remain, changing M against what, changing Y. All right. So that's why it's good for you to know your graph you are plotted and not using the normal O-level formula, changing Y, changing X. If you bring that here, you cause more problem than any other thing. All right. So now, like I said, this is a sample work. So we are just saying that, okay, let's say that S40 is 23.45 gram per cm, which is also based on what somebody have done. So I just have to bring up that here. Then let's say S60 is 162.25 gram per cm. Note, you will get something of that nature. Yeah. So this is just a guide. So you get something of this nature. So take note of that. Your own might be 30, might be 25, might be 26. Then the last time might be around 170, 155 or so, but 100 and something. That's what you get. So going to question 3. I just mentioned that for you to correct that in your manual. So in the question 3, we are going to transform the equation, which we divide through by y. We got m over y equals to this. You can see that. So m over y represents our slope. That means our slope is equal to bd cube y all over g 4gl cube. Okay. So that is question 3. Though the statement was not complete in the question 3. Yeah, they just gave the statements. It's a given that this is, but they didn't tell us what to do. But we expected to transform the equation accordingly. Okay. So yeah. Okay. Just hold on. Please give me 1 minute. Okay, so please, if you have not subscribed to my channel, please click the subscribe button. Please click the subscribe button now. Just click it now while I'm waiting for you. Okay, have you done that? Right, let's go. Okay, question 4. Question 4 now, we are about solving the value of y now using the two graph. So we make y subject formula. Okay, so you cross multiply 4g L cube times your slope. M over y is your slope. Then divide by BD cube. So you get this equation here. Now, if you come down, let me screw this. If you go up there, you see where g is 980 cm per second square. For us to get the actual units, for everything to be in the standard units, we converted our g, which is 9.8, to 9.8 meter per second square to 980 centimeter per second square by multiplying by 100. Then our L remained 40 cm or 60 cm. The meter rule thickness we had that of 0.15 cm. That was one that was gotten from one group. Then the breadth is 2.5 cm. Then now for S40 we do the calculation, so you can see everything there. For S40 we do the calculation. Okay, so we put in the values. Our slope for S40 is 23.45 as we assume, times 4 times 980 times 40 cube, because we are treating S40, we are treating for L40, so that's why we put the 40 for that. Then B is 2.5, G is 0.15 cube. So you can see there. Press calculator, be very careful with the standard form. You get a very high value, about 6.95, 6.97 times 10 power 11 Newton per meter square, which is a unit for what Young modulus. Then also for S60, okay, so we also do the same thing. Our slope is 162.25, then times 4 times 980 times 60, because it's L40 L60 we are discussing, of raised power 3. Then the BDQ remain the same. So here we are having about 162.8 times 10 power 11. So average value now, because we are talking about the Young modulus of that meter rule. Okay, that's a meter rule. So we want to get the average value. The essence of doing this is for accuracy. Okay, so accuracy. So we'll go for the average value. So the average value is going to be adding the 2 dividing by 2. So that will give us about 84.895 times 10 to the power 11 per meter square. So I just make a statement and say, please use your B and D value. So you can use your B and D value, which you recorded in the lab, but if you didn't get it, this value is not far from the truth. This was the value that was gotten by some students some years back. All right. Now, I mentioned something here. Just remember, like I said, this material is to guide you. So that's why I'm making some statements here. I said to compare with theoretical value, you need to know the type of wood used to produce the meter rule. You use then. Okay, you use. Router you use. Then check for the Young modulus value online. That's all. Call me to send a table of full Young modulus value for wood, or Google Young modulus for wood. Click the first link, you will see a table. Okay, so I was just doing it so that everybody will understand where we are driving at. Okay, if you go online and check a Young modulus value, I think, can we do that now quickly? All right, so before we do that quickly, let's just answer question first so that I can just show you that of the question 4 before we round up in this very section of the practical. So number 5 was asking, will a change of the breadth and thickness affect our Young modulus value? Now the answer is no. Yes, the answer is no. Now what you need to understand is that Young modulus is a material property. Do you understand? It's a material property. What example can I use to explain this? Okay, what example there? Okay, now let me just say generally. If we talk about the properties of, let's say, mahogany or melina tree or wood, okay, now Whether the wood is small or big, that property still holds for that very material. Are we there? Whether it's small or big, that property still holds for that very material. It does not affect, it does not change. You understand? What I'm talking about, a bigger one, a bigger size of that very material or a smaller one, you still have the same property. Just like you having a chalk, okay, the chalk, the one we use in writing, and then you break the chalk into three. Right there, that chalk still retain the same property as those of the original chalk. You understand? It still retain that same property. The only thing you might say, okay, maybe the size and whatever has been cut, but young modulus is an inherent property. It's a material property that talks about the stiffness of that material. Okay, so you can see they talk about a property that determine the stiffness of the material, and it will respond to, okay, that will make it to respond to what, and how it will respond to what to apply for. So it does not depend on whether breadth or thickness. It's an inherent property of that very material. So that is that for this very experiment. So please feel free to ask questions. Check my YouTube channel playlist for other videos. Check my WhatsApp group, okay, for different WhatsApp group for your one student, just to explain this. And of course, I'm not only doing video for physics practical, I also have physics and 101, then you have mathematics courses, okay. The maths 110, 120, 101, 102 practicals, teaching, they're also there. So feel free to check the playlist to go to the video. These are based on what is being done. Like I said, my base is in Uniport, but every other students who are also working towards this scheme and this work can also benefit from the video. All right, so I promise to show us, for us to go over to the internet, okay, to check oh, my battery is very low, to check set of young modulus of materials, okay, set of young modulus of materials. I think that is the last thing I'm going to do in this video. Let me use my this thing to do that. Okay, young modulus of material. So come here, say young of wood. Let's see how the network is good to go. All right, I didn't want this video to be more than 35 minutes. Is it connected? Okay, young modulus of wood, young modulus of wood, young modulus of residual wood. Let me see, I can get a table of young modulus, how many young modulus of wood along. So you can see that there's so many experiments they are working up. Table of value. So you can actually check this table of young modulus of wood. Okay, wood, elastic modulus and Poisson ratio, no. Young modulus for some common materials, PDF, young modulus for some common materials. Okay. I want to check for that of wood. Let me check for that of wood. Wood is what I'm interested. Okay, so you can see wood here. Kind of wood, moisture contents, young modulus of elasticity. So you can see there. Let me drag this up here. So you can see there. You can see the value about 10 raised per 6 here. Hardwood, they have hardwood, they also have softwood. So this is about this one is a megapascal, while this one is in other PSI. So 0.1, okay, megapascal. Mega is about 10 raised power 6. So 9.9 or 8,100, okay, raised power 6. So that raised power 6, abi, yeah, giga is 12, mega is 6. So if you add up the, we are going together by 8. So 8.1, 9.5, 9.9, 12.0, 7.2, 10.1, you can see the different materials, different wood have their different young modulus value. So you can see it down here. So these are softwood too. Cypress, cedar, northern cedar, western red, Douglas fir, coast, different materials. You can see their young modulus. So any value you get, you notice that it's going to. So why we cannot specifically mention the theoretical value, because we don't know the material by which that very metal you are using was made up of. So that is the problem. So that's why I do make those statements, so that you come online and see exactly what you did. Okay, so I think we'll stop here for this very practical session or this very video. So please, like I said, check out other materials, forward this to your loved ones, share, like, and then of course follow, and make sure that you're always updated on my channel to get the best out of it. Okay, I'm always here to help students on campus, to make the work easier, because I know what it is in teaching. Coming to university with a very poor foundation in physics, mathematics, and then of course practicals like this. So that's why I find out time to ensure that we get all this done. Okay.